So carrying on with the esters, and I said ester is a combination of a reaction, basically a chemical reaction, the condensation type, esterification, the type condensation, because carboxylic acid and alcohol molecule reacts and a little molecule H2O leaves from the middle, and rest of the molecule has a functional group, ester functional group. Okay, COO, and this side should have C. With single bonded oxygen there should be C. It may be H here, okay, that may makes it as methonate, but this side O should be accompanied with a C for a carboxyl functional group. So esters, which are made basically, and they are used as flavors and odors and solvents, okay, and esters are basically the organic compounds, and since they cannot mix with water, are very slight soluble in water, so when you produce basically an ester and carry out esterification process in a small test tube, the small observations may be you will feel fruity smell, and there will be always two layers seen. So two observations, a fruity smell and two layers seen. Immiscible they are, because this is organic layer and this is aqueous layer. Okay, so look at this. This is basically butyl methonate. This is made up of this part, I stressed earlier as well, this part, butyl basically come from butanol, and methonate mean 8 from acid to oxygen, it contains methanoic acid. So when it is written, basically it is, when it is written, it is in English alcohol group comes first and then the acid. But if you draw a structure of it, the combination of these two mean methanoic acid and butanol, the product should be like this. The methonate part come first and then the butyl part. So you notice it like this. This is butyl and this one is what? Methonate. I mean, if you hydrolyze it, then hydrolysis will yield methanoic acid and butanol. So to make things easy to remember, remember carboxylic acid written first, alcohol afterwards, OH from here and H from there, or OH from there and H from here, basically you can at this level, but technically OH from this side, H from here will yield the carboxylic acid, will yield the ester, sorry, and in this case it is ethyl ethanate, or in this case this is butyl methonate. So we can practice making alcohols, we can practice making esters by using variety of carboxylic acid and variety of alcohols, but always the criteria should remain the same, OH from here, H from there, rest of the molecule condenses and turns into the respective ester depending on what kind of the alcohol or carboxylic acid is used. Okay, fine. Sometimes you may be asked to like hydrolyze an ester or retrace the product of reactants that are involved in basically the esterification, like it can be any ester molecule, C3H7 COO, and it can be C2H5, or you can write it in condensed form like this. So this is an ester. How you recognize it? Because this is the ester functional group, and to this side it is C. If we draw a displayed formula of it, this is a bit condensed one. If we draw, it can be even condensed like this, C3H7CO2 C2H5. So never think it's carbon dioxide being embedded inside the alkyl groups. It is not. This is ester functional group, way of writing in organic chemistry. If we ask draw a displayed formula, count the carbon here, how many? 3 there are. One is involved in functional group, and then this side has 2. So displayed mean show all the bonds. All the bonds. Do place hydrogens, okay? Instead of these line diagrams, always you are supposed to put hydrogens all around. Okay, so this is what? If you want to name it, then this oxygen has attached alkyl group, 2 carbon atoms, ethyl, and this whole part attached is from the acid, 1, 2, 3 carbon acid. This is proponate. So this is ethyl proponate. And if you want to hydrolyze it, mean hydro, water, lyse, break it, split it. You want to hydrolyze it, then add H here and OH there. And you will find out it will change to what? Ol. it will change to propanoic acid, and this to ethanol. H to this two oxygens, so it turns into a respective carboxylic acid, and OH there, that is ethanol. So any carboxylic acid and alcohol will react to produce an ester, and ester is hydrolyzed back. That is why when it is basically digested inside the small intestine, it should hydrolyze into the respective carboxylic acid and alcohol. Okay, so esters, very useful products, and you need to know that esters are a combination of carboxylic acid and alcohol, and I stressed earlier on, do go for the conditions. Concentrated sulfuric acid acts as what? Catalyst, and heat, and when you heat you put a reflex condenser, so the alcohol never vaporizes. Respective alcohol and carboxylic acid will produce the ester and water, and hydrolysis basically will yield the carboxylic acid and alcohol back. So this is basically the esterification. You need to practice a variety of carboxylic acid by just choosing a carboxylic acid of your choice. Like this is methanoic acid, and suppose this is what? Methanol. 1 carbon alcohol, methanol. 1 carbon acid, methanoic acid. And remove this OH and H from there, and rest of the molecule, you see, it's easy to draw. Combine, and you want to name it. Okay, so you know that you want to name it. This single bonded oxygen, put a line there. This is methanol, and this is methonate, methyl methonate. So simple as an ester. Okay, and if you want to make isomers of esters, if a question says easy, there are 3 carbon atoms to this side and 2 to that side. Shift 1 carbon atom here, it will turn to methyl butanate from initial ethyl propanate. Or you shift 1 carbon atom there, so you can isomerize. Isomerize means same molecular formula but different structural formula. Or if sometime a question says you should make an isomer of an ester, there should be a carboxylic acid. Mean write an isomer of an ester, there must be a carboxylic acid. Don't worry then. Simply in the whole molecule count what? 1, 2, 3, 4, 5 carbon atoms and hydrogen atoms and oxygen. 5 carbon atom in the whole molecule mean we can make what? A carboxylic acid containing 5 carbon atom. 1 this and 4 this. Pentanoic acid. I repeat again, if a question says you should make an ester, you should make an isomer that is basically a carboxylic acid of that particular ester. I mean, one way to make isomer is just shift in the position of the carbon from there to here. Another is count the number of carbon atoms, whatever they are, change that into a carboxylic acid. 5 carbon atoms are there, make a 5 carbon atom carboxylic acid, pentanoic acid. Okay, if it is 4 carbon atom, butanoic acid. So I mean that is one way, although they are different. This is different class and this is different class, but isomerism has a definition, same molecular formula, different structure formula. Just like for propene we have cyclopropane, or butene we have cyclobutane. So it means it's not always a fixed rule, rigid rule that class should remain the same, class family should remain the same. No, it is not. Structural formula, molecular formula should remain the same, molecular formula to be precise. So esters are wonderful molecule because perfumery they use, perfumes they are, dissolve things, so many organic things like cosmetics, nail polishes, and their odors used in bath soaps and all that, and esters are used as flavors. So huge variety of these esters are there in the industry, but they are product of carboxylic acid and alcohol formed by a chemical reaction called condensation. Esterification is a reversible reaction. Okay, so hardly goes to completion. When we hydrolyze esters, we get back the carboxylic acid and alcohol they are formed. Okay, there is esterification.